Explain how you can use side, 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 angle, or angle, angle, side with the definition of congruent triangles to prove angle D and angle B congruent. Well, first of all, DC is congruent to segment BC. And we know that angle DAC is congruent to angle ACB. And they share the same side. So both triangles are congruent because of side, angle, side postulate. Because of corresponding parts of congruent triangles are congruent, then we can say angle D is congruent to angle B. The legs of an isosceles triangle have lengths x plus 1 and negative x plus 7. So I have, here is an isosceles triangle. These legs are congruent, so you have x plus 1 and negative x plus 7. The base has a length of 3x minus 3. What is the length of the base? Well, I know that the two sides of the isosceles triangles are congruent. So you have x plus 1 equals negative x plus 7. Now we have to solve the equation, so we add x to both sides. So we have 2x plus 1 equals 7. Subtract 1 from both sides. So you have 2x equals 6. And so the last step is to divide by 2, so x equals 3. Now we're trying to look for the base. So you have to substitute 3 times 3 minus 3. So 3 times 3 is 9, 9 minus 3 is 6. So the length of the base is 6 units long. And the length of each side is 4 units in length. For which situation could you immediately prove triangle 1 congruent to the hypotenuse leg theorem? For the HL theorem to be true, the hypotenuse has to be congruent and the legs have to be congruent in both triangles. So for triangle 1, the hypotenuse is not congruent here. So you can't use the HL theorem. In answer 2, they are congruent because of side, angle, side, but HL theorem, no, because we don't know if the hypotenuse is congruent immediately. So it can be 2. So the only one that you can prove immediately triangle 1 is congruent to triangle 2 would be 3, because the legs are congruent and your hypotenuse is congruent. So your answer is 3 only. For problem 8, what I did is I went ahead and constructed 2 sketches here. We have for triangle RST and triangle UVW. We have angle R congruent to U. We have segment ST congruent to segment VW, and angle S is congruent to angle V. Now, if we're going to use angle side angle, we would have had to had segment RS congruent to segment UV. Or you could have had angle T congruent to angle W. So you could also have had angle T congruent to angle W. So those are the 2 ways that you could have used angle side angle. That's what you would explain in your test. Number 10, RQ is a perpendicular bisector of segment PS. And you noticed I drew RQ. So RQ is this line that's here that's vertical. And then PS is this line that's horizontal. If they're perpendicular, it forms a 90-degree angle. And it's a bisector, so these 2 are congruent. This is the midpoint. So the only postulate that you can use here to prove triangle PQR congruent to triangle SQR is going to be side, angle, side postulate. Write the missing reason to complete the proof. We're given segment AB is congruent, and AB is just this part. And segment CD is just this part. Is congruent. Segment AF is congruent to segment ED. And we know that angle A is congruent to angle D, and we're trying to prove if triangle 1 is congruent to triangle 2. So the first statement is given, the second statement is given, the third statement is given. That's what I just went over. AB is equal to CD. Well, we know that because it was given to you. AB equals CD. So now what we're doing in the next step is we're adding BC, we're adding BC, and we're adding BC. So that's addition property. That's addition property. The next one is segment addition. The next one is definition of congruent segments. So this segment is congruent to the other segment that's overlapping. So why are the two triangles congruent? Side, angle, side, postulate. It's just that these two sides are overlapping, but the two sides are congruent. So this side is corresponding with this side. This angle is corresponding with this angle. And these sides that are overlapping are congruent. So that's the reason why the two triangles are congruent. This is a flowchart proof. Angle ADB and angle CDB are right angles. Angle A is congruent to angle C. And you have triangle 1 and you have triangle 2, and they share the same side. So why would these two triangles be congruent? Well, you can see it's going to be this angle corresponds with this angle. The right angles correspond with each other, and then the sides are congruent. So this should have been angle, angle, side. So let's go ahead and follow the proof. Angle ADB and angle CDB are right angles, that's given. Angle A is congruent to angle C, that's given. The two triangles are right triangles. Well, that's definition of right triangles. BA, segment BA is congruent to segment BC. Well, we know that this angle is congruent to this angle. So because of the Isosceles theorem, or the Isosceles triangle theorem, we know that the opposite sides are congruent. So you can just write definition of Isosceles triangle. And we know that segment DB is congruent to segment DB, which is going to be reflexive property. I don't know if you're able to see it, but I'm going to write it again, reflexive property. And since this is the hypotenuse, and this is the hypotenuse, and these are the legs, and it's a right triangle, they are congruent because of the hypotenuse leg theorem. Find the values of x and y. I do know that this angle is congruent to this angle. I do know that this side is congruent to this side, and because it's an isosceles triangle, this is 46 degrees. Now, 46 plus 46 plus the larger angle, which I'll say is L, is equal to 180. I know that the base angles are 46 plus 46, which gives you 92. So 92 plus the large angle is equal to 180. That's where I'm at right here. Now to find this entire angle, which is angle A, I'm going to have to subtract 92 from 180, and that gave me 88. Now 88 is a measure of the entire angle, so if I just want y, then it has to be 88 divided by 2, which gives you 44. So this is 44. Once again, the sum of the angles in a triangle is 180. So you have x plus 44 plus 46 equals 180. So x equals whatever 44 plus 46 is. So 46 plus 44 gives you 90. You subtract 180 minus 90, so that angle is a right angle. So the measure of angle x is 90, the measure of angle y is 44. Is triangle ABD congruent to triangle CBD? If so, name the legs that allow you to use the hypotenuse leg theorem. So it is congruent, so triangle ABD is congruent to triangle CBD because they share a leg. They share DB. So DB is congruent to segment DB, and you know that that's going to be reflexive property. That means it's congruent to itself. Number 20, we have, we know that this is isosceles because this side is congruent to this side. So these two sides are 21, so these two angles, which are the base angles are congruent. So you have 2x plus 38 equals 180. The base angles are congruent. So now we subtract 38 from 180, and whatever we get, we're going to have to divide by 2. So I have 2x equals 142, because I subtracted 38 from both sides. Then I divided by 2. So x is equal to 71. It is the same distance from home plate to first base as third to home. The angle formed by first and home is the same as the angle formed by third and home. So here we have. So we kind of have these two triangles here. You see that? And these two triangles share the same side. So to begin with, we know that triangle 1 and triangle 2 are congruent. And the reason why is because of side, angle, side. And because of CPCTC, that means corresponding parts of a congruent triangle, we can also say that this distance is the same as this distance. So first, you got to prove that the triangles are congruent, and we did. Side, angle, side postulate. Second, we know that its corresponding parts of congruent triangles are congruent. So yes, the other two distances are congruent, so they're the same.